Okay, in this video, let's continue the section 1 in the review chapter. The third part of this section 1 is the evaluation of a numerical expression. Evaluate numerical expressions. Okay, so first let's talk about the addition and multiplication. Addition and multiplication. In the textbook, here's the example. So first, when you have addition together with multiplication, we always do multiplication first, addition second. Okay, so with addition and multiplication, we always compute multiplication first, then the addition. Okay, so it's always this way. When you only have addition and multiplication. So for example, it doesn't matter which order you have. For example, in the textbook, they provide several examples. If you have a 3 plus 4 times 5, you're going to compute this 4 times 5 first. You copy 3, 4 times 5, 20, and then you add a 3 with 20, you get 23, right? So I only do this one. And if you really want to compute addition first, you need to put parentheses. Okay, so we use parentheses to compute addition first. Here, don't just read and memorize this sentence. Memorize the example. Actually, we compute whatever inside parentheses first. Okay, let's cross it. To compute whatever inside parentheses first, not addition. If addition is inside parentheses, you're going to compute it first. So the same thing. For example, if you have 3 plus 4 times 5, but this time you want to compute 3 plus 4 first, you must put parentheses. You put a parenthesis, then it means you're going to compute this internal stuff first. So 3 plus 4 is a 7. 7 times 5 is 35. So see, that's totally different. Okay, so you have to use parentheses to change the order of the computation. All right, it's very important. So also, for example, if you have 5 plus 3 times 8 minus 2, you see you have two pairs of parentheses. You're going to compute 5 plus 3 first and 8 minus 2 first, because they are both inside different parentheses. So you will get 8 times 6 is 48. After you clear the value inside parentheses, you're going to compute the product. All right? Okay, so next, if we have the division or the ratio fraction, so for example, if we have 2 plus 3 over 4 plus 8, this fraction separate expression into two parts. It actually acts like you put parentheses for top and for bottom. Top and bottom are two different regions. You're going to compute the top and the bottom separately first, and then you're going to evaluate the fraction. So 2 plus 3, 5. 4 plus 8, 12. Right? So don't do the cross computation. It is separated by this horizontal segment. All right? So let's see the example. Well, the simple one means it has no parentheses. Then you're going to follow multiplication, addition. So 2 times 8, 16, plus 3, 19. Correct? If it has parentheses, you're going to compute this first. 3 plus 4, 7. So it's a 5 times 7. You do not change anything else. You first compute the You first compute the internal of the parentheses. And then 5 times 7 is 35. 35 plus 2 is 37. Everything should be in this order. If you have fraction, remember it has two different regions. For the top, you get 2 plus 5. It's just 2 plus 5. It's 7. For the bottom, it is 2 plus 4 times 7. So you have to compute 4 times 7 first. 4 times 7, 28. And then you add the denominator. You see here, denominator is 2 plus 28 is 30. So the expression is a 7 over 30. Okay? Yeah, I'm sorry about the blur of the few part. You just check this. Okay, and next, if you have several layers, you will use different pairs of either parentheses or the bracket or braces. Of course, you can use the same parentheses, but sometimes if you have multiple layers, you use one type of a symbol, it will be confusing. So here, you see, first you see this a parenthesis. Inside the parenthesis, there's nothing. So you're going to compute this first. When you handle the internal stuff, you copy everything else. So 6 plus 10 is a 16. And you copy the bracket. And the bracket, inside the bracket, you have a simple expression. So 4 plus 2 times 16. So 2 times 16 first, it's a 32. And 4 plus 32, 36. And 2 plus 36, 38. Okay, you just simplify them step by step. Okay. In the pre-calculus and the calculus, without specific saying, we prefer the fractions. We don't use decimal numbers. So I would like you to use 5 over 2 instead of a 2.5. So use fractions, don't use decimal numbers. Okay? Well, I'm not saying you use 2.5 is wrong. I just say I prefer you use these fractions. Okay, so that's the basic evaluation of a numerical expression. Now let's just list the basic properties of the real numbers together with operations. Okay, so first, the basic properties with the real numbers. Work with property of real numbers. Okay, so let's see the list of the four property. The first property is called reflexive property. The reflexive property states that a number always equals itself. Number always equals itself. That is, A is always equal to A. This is equality. Well, it's obvious, right? Let's just list it. For some certain reason, we need this type of stuff because we do have the equality, two sides of equality, left side, the right side. So they are naturally different. One is on the left side, the other one is on the right side. But for the number A, you can place one A on the left side, one A on the right side, you still have the same thing. Okay, that's called the reflexive property. And second, the symmetric property. The symmetric property states that if A is equal to B, then B is equal to A. Okay, so it doesn't matter which term is on the left side, which term is on the right side. Once you have equality, you can just naturally exchange those two sides. Okay, so this is a symmetric property. 3 is a transitive property. The transitive property states that if A is equal to B and B is equal to C, then A is equal to C. Well, it's obvious, right? That's one of the property for the equality. And 4, the principle of subtraction. The principle of substitution, my bad. The principle of substitution states that if A is equal to B, then we may substitute B for A in any expression containing A. Okay, so whenever you have the equality A and B, then when you see A, you can freely use B to substitute, right? So that's the property, the principle of substitution. Here's the transitive property, here's the symmetric property, here's the reflexive property. All right? Okay, so there are other properties. This properties is about the equality. Other properties are about the operations. So we know the so-called commutative property. Commutative property. Commutative property. Commutative property is the following. When you have two numbers, A plus B, it is equal to B plus A. and A times B, it is equal to B times A. You see here, it is about the operation. The numbers have two basic operations, addition, multiplication. Subtraction and division are the reverse operations of addition and multiplication. Okay. So here, whenever you have addition and multiplication, you can naturally commute those two places. But be careful for the subtraction and division, you can never exchange those numbers, correct? So that's a commutative property. And the other one is called the associative property. What is associative property? The associative property means you can add three numbers in whatever way. You can add the last two numbers first and the first two numbers, and then the first number. Or you can add the first two numbers first and add the third number. So this is associativity. With this property, you don't worry about order. Just write A plus B plus C. I don't care how you do this computation. Right? You can add these two first or the first two first. This is addition. Multiplication also has this so-called associativity. You can just choose your favorite order to compute, or the effective order to compute the sequence of a product or the sequence of a sum. Associative property. And one of the property listed in the field axioms is so-called the distributive property. The distributive property says you have the sum addition with a multiplication, and then it is equal to A times B plus A times C. You distribute this A into the parentheses. All right? And for the completeness of the distributive property, we also list the second term. This multiplication from right side as one of us separate stuff. The distributive property has nothing to do with the commutativity of a product. So that's why you need to list two properties. Because if you combine the commutative property, you will see this one is equal to this, and the C times A is equal to A times C, and this product is equal to the left side of the first term. So with commutative property, you don't have to write the second row. But since we're trying to list the complete distributive property, we have to list both. Assume we don't know the commutative property. All right? Okay, so why we list those simple properties? It's because we actually use them all the times when we try to do some formal computation. For example, if we have 2 times x plus 3, what do? We actually do the distribution, do the distributive property. 2 times, it is equal to 2 times x and 2 times 3. That's how we compute it. And sometimes we can factor out. We say, let's factor out the number 4, or let's factor out number 3. So here, if you have 3x plus 5x, how do you do that? They have the common factor x. So you factor out x, you get 3 plus 5 times x. This is exactly the reverse way of a distributive property. You just read the property from right side to the left side. It's a factorization property, right? Okay, and this is 8x. You combine similar terms, you use the reverse distributive properties. So here, let me see. When you combine similar term, combine, you use the reverse distributive property. Correct? You just read from right to left. Distributive properties from left to right. And another one is identity. Identity, remember, that's also part of the field axiom. We have 0 plus any number equal to A, either from left or from the right. And we have 1 times any number is equal to A, from left and from to right. This is a additive identity. This is multiplicative identity. Of course, we assume 0 is not equal to 1. 0 is not equal to 1. What is, or why do we assume this? Even though we know this is always correct, why do we assume this? It's because if 1 is equal to 0, this everything, you see here, if 1 is equal to 0, remember we know that 0 times anything is equal to 0. But 0 is equal to 1. Assume, we say. If 1 is equal to 0, then 1 times A is A, and 0 times A is 0. Then A is equal to 0. So all the numbers are 0. That is a weird field. It does not include a lot of stuff, just 0. Okay, so anyway, it's just too far from us. So we ignore it. We always know 1 is not equal to 0. We have a additive identity. We have multiplicative identity. Okay. And we also have the additive inverse property. The additive inverse property means every number has its additive inverse. Additive inverse means the sum of them is equal to 0. Correct? So technically, when you write this, if you ignore the parentheses, you will write A minus A is equal to 0. Right? A minus A equal to 0. It looks so simple. And any expression B minus A, if you have subtraction, if you have a subtraction, you can always write them as a addition, but you just add the additive inverse to B. Correct? You can always change everything to the addition, but sometimes this second number should be the additive inverse. And for the additive inverse, you always put negative sign. So 6 has its inverse negative 6, and negative 8 has inverse negative 8. Remember, we know that if you have 2 negative sign, they canceled, you have a 1, you have 8. Right? You always put additional negative sign to find negative sign directly to get the additive inverse. Get the additive inverse. All right. And except additive inverse, we also have so-called multiplicative inverse. Multiplicative inverse means for a non-zero A, the A is a number, this is a word. For a non-zero A times 1 over A and 1 over A times A is equal to 1. This 1 over A is the multiplicative inverse of A, the reciprocal of A, the reciprocal of A. Reciprocal, you just put it in the denominator position and leave the numerator 1. You always do that. So 6 has the reciprocal 1 over 6. And negative 3 has negative 1 over 3. And if you have a fraction, just exchange the numerator denominator. You exchange the numerator and the denominator. Correct? Yeah. And like the addition, remember that we just mentioned the subtraction is the addition with the additive inverse. The division is also equal to the multiplication with the multiplicative inverse, right? So B is divided by A. B divided by A is equivalent to B times 1 over A, right? So you can always write it this way, right? So it doesn't matter how you write it. This is B over A. B is divided by A, the same thing. Of course, in this part, the denominator is not equal to 0. The denominator is never equal to 0. Okay? And we actually just mentioned, let's just list it. 0 times every number is equal to 0. 0 over any non-zero. Here, A is for all A. Okay, for all non-zero A. And 1 times A is always equal to A for all A. Okay, so 0 times any number is equal to 0. 0 over any number is equal to 0, but this, when you do, whenever you do fraction, you do the division, make sure that denominator is not 0. So that's why we have to claim for all non-zero A, you can put it in the denominator. All right? And of course, A over A is always equal to 0. But you see here again, for all non-zero A, you have denominator, then the denominator is not 0. And always keep in mind, division by 0 is undefined. It doesn't matter how much mathematics you have learned, the division by 0 is not allowed. It's never allowed. Okay. And we also have the rules of the signs. What are the rules of signs? If you have for the product, if you have one negative sign, you can give it to whatever factor. You can put this negative sign with the second factor or with the first factor or before them. Okay? And if you have two of them, then it is equal to AB, because the first one factor, the second one factor, -1 times -1 is 1. So that's why it disappears. So negative and negative is positive. Negative, negative, positive, right? And this is product. For the quotient, it's a similar. When you have a quotient and a negative sign, you can place it on top, on bottom, or in front of this fraction. And if you have two negative sign, they are automatically cancel each other. Okay, so you can write whatever way, but in most cases, if you write in the answer, we prefer the negative sign in front of this expression, only for the final answer. And next one, cancellation. What is a cancellation? We want to simplify the rational expression, or we want to simplify the equation. For example, if you have A times C equal to B times C, we always say, okay, let's cancel those C. But when you cancel this C, make sure this C is not equal to 0. If AC equal to BC and the C is not equal to 0, then A is equal to B. You must include C is not equal to 0. You can only cancel a non-zero number. This is for the equation. For the quotient, you have the same thing. If you have a AC over BC, of course, you can cancel C, you get A over B. In whatever case, B cannot be 0, it's a denominator. C cannot be 0 because you cancel C. Also, if C is 0, the denominator is also 0. Okay? So just keep in mind, whenever you cancel a common factor from two sides of the equation or from two sides of the rational expression, make sure that it is never equal to 0. It is never equal to 0, okay? Okay, so the example will be standard. So for example, if you have 2x equal to 3, we all know that we are going to divide this equation by 2, or we say let's cancel 2 from two sides, because 2x is equal to 6. 6 is 2 times 3. Here's 2 of x. 2 times x. 2 is not equal to 0. So you cancel 2, you will get x is equal to 3. So you can say let's cancel 2, or you can say let's divide the equation by 2. The same thing. Okay? Yeah. And second, if you have 18 over 12, you see that 18 is the 3 times 6. 12 is 2 times 6. The top and the bottom both have the common factor 6. And 6 is not a 0. So you can cancel 6. You get 3 over 2. This one is simpler than 18 over 12. So that's a cancellation. Simplify rational expression. Okay, simplify rational expression. Okay. Okay, next, it's a zero product property. We have many properties. Zero product property. Zero product property says if A times B is equal to 0, be careful, this is only for 0, then either A is 0 or B is 0, or both. either A is 0 or B is 0 or both. This is extremely useful when we try to solve the equations. Here I just gave you a quick simple example. Later we will see more examples. For example, when we have x squared is equal to x, you see the left side is x times x, right side is x times 1. They, on two sides, they both have the common factor x, but you cannot cancel x here. You cannot, I emphasize, you cannot cancel x here, because x is a variable. A variable may or may not be 0. There's no any condition which will tell you x is not equal to 0. Okay, so whenever you cancel something, you have to be 100% sure that stuff is not 0, is not possible equal to 0. Here you don't know that, so you cannot cancel x. Okay, so I put this example here, just emphasize again and again, you cannot cancel x at this step. The correct way is the following. You move this x to the left side, it becomes subtraction, right? We all know that. And then you see here's x squared, here's x. They have the common factor x. That's a way of this distributive property. And then you see a product is equal to 0. A product is equal to 0. So AB is 0, then you use 0 product property. AB is 0, then you get either x, the first term is 0, or x minus 1 is 0. Or both. Both is 0. It's impossible. One is x equal to 0. The other one is x minus 1 is 0. They cannot be 0 at the same time. Okay? Okay, so x equal to 0 or x minus 1 equal to 0. Then you get x equal to 1 or x equal to 0. You move this 1 to the right side, you get x equal to 1. So this expression is equivalent to, has a solution set x equal to 0 and x equal to 1. You see here, x may be 0, could be 0. So that's why you cannot cancel it. Okay? So this is the final complete answer. If you do the cancellation, you will just have one answer. You lose one answer. That's wrong. Okay? So 0 product property, it is a very important one. We try to find the solution of equations. Okay, then we have the addition of fractions and multiplication of fractions and the division of fractions. So 15, arithmetic of quotients. What is the arithmetic of quotient? If you have two fractions, a over b plus c over d, remember you have to find, you cannot directly add them. You cannot add them because they may have different denominator. In order to have the same denominator, in abstract, we're going to multiply top and bottom by the same factor d. D is the denominator of the second quotient. It's the reverse way of a cancellation. And for the second factor, we multiply top and bottom by the denominator, first quotient. And now you see the denominator becomes b times d, they're the same. When you have the same denominator, you copy one denominator and combine two numerators. Okay, so that's a way to do the addition of quotients. And of course here, b is the denominator, b is not 0. D is the denominator, d is not 0. So we have to make sure b, d are not 0. This is addition. Addition is a little bit complex. You have to have the common denominator in order to do that. And multiplication of two quotient is simple. Multiplication means you do multiplication of a numerator, multiplication of the denominator. Multiplication of two quotients is a simple job. Numerator for numerator, denominator for denominator. If you have the quotient of the quotient, you are going to first flip this denominator and change the quotient to be the multiplication. You flip the denominator, change the division to be the multiplication. Multiplication is A times D, B times D. Of course, whenever you see the denominator is not equal to 0. So B is the denominator, B is not equal to 0. D is the denominator, D is not equal to 0. So here C is denominator, C is not equal to 0. Okay? In this expression, only A never be in the is never in the denominator part. So A can be 0. And here the same thing. B is not equal to 0. D is not equal to 0. Okay? So here I want to emphasize this expression. This expression is better for you to write it in the extremely clear way, so that I see you have this quotient over this quotient. It's because, for example, let me say, make it this. For example, if you write 2 over 3, and then let's put over 4. Then by the definition, it means 2 over 3 times, you flip this denominator. You find the reciprocal. Reciprocal is 1 over 4. The reciprocal of 4 is 1 over 4. So it is 2 over 12 is 1 over 6. Okay? And what happens if we have this way? It's 2 over 3 over 4. You see, by this writing, I prefer 3 over 4 as the denominator, 2 as the numerator. Then follow the quotient. It's 2 times 4 over 3. Remember, you just flip this denominator, get the reciprocal, and change the quotient to be the product. And this 2 times 4 is 8, 8 over 3. You see, these two values are totally different. So be careful about the quotients of the quotients. Make sure you write it very clear. Otherwise, you may get the wrong answer. All right? So let's just do one example. So for example, if you have a 2 over 3 plus 5 over 2, you're going to multiply the first expression, top and bottom, by 2. It's a 4 over 6. You're going to multiply second quotient, the top and bottom, by 3. It's a 15 over 6. Now it's a 4 over 6, 15 over 6. They have the common denominator 6. Then the 4 plus 15 is 19 over 6. So this is the right answer. Correct? Yeah. And if you have a quotient, division. Subtraction. Yeah, this is the right word. Subtraction. Subtraction is done by the same way. So you first multiply top and bottom by 3. So you get a 9 over 15. Subtract. Second one, top and bottom, you multiply top and bottom by 5. It's a 10 over 15. And they have the same denominator, 15. The numerator, it will be 9. This time it's a minus 10. 9 minus 10. This is subtraction. Here's the addition, so you copy addition in the numerator. Here's the subtraction, you copy subtraction in the numerator. So negative 1 over 15. 9 minus 10, of course, is negative 1. Negative 1 over 15 is negative 1 over 15. Okay, well, let's complete this example. Okay, so 8 over 3 times 15 over 4 is 8 times 15, 3 over 4. Well, we can do some cancellation. 8, 4, they can cancel 4, so you will only have 2. 15 and 3, you cancel 3, you will have 5. So the denominator is totally cancelled. The denominator becomes 1. After cancellation, denominator, if there's no denominator, it's 1. So 2 times 5, this is still product. 2 times 5 is 10. So 10 over 1 is 1. Let me write it. It's a 10 over 1. It is equal to 1. Okay, after the complete cancellation, if there's no denominator, all the numbers are cancelled, it is 1. And next, 3 over 5 over 7 over 9. By the property, you're going to flip the denominator to be 9 over 7 and do the multiplication. Multiplication, it's a 3 times 9, 27, 5 times 7, 35. Sounds right? Okay, so sometimes when you do this addition of two quotients, for example, let's try this. For example, if we use 1 over 6 plus 1 over 8, how do we do that? Based on the previous experience, we're going to multiply top and bottom by 8. For the first one, the second one will multiply top and bottom by 6. And then we add the numerator together. 6 plus 8 is 14. And you will see this 14 is 2 times 7. 48 is 2 times 24. So they both have number 2. Factor 2. We cancel factor 2. We get 7 over 24. We cancel 2. We cancel 2 here. From top and bottom, we get 7 over 24. There's a way to simplify or to avoid the final cancellation step. It's so-called the least common multiples. Least common multiples. Let's check. For 6 and 8, 6 has multiple. What is a multiple? 12, twice of 6. 18, 3 times of 6. 24, 4 times of 6. What's next? 30, 5 times 6. 36, 6 times 6. 42, 7 times 6. 48, 8 times 6. And 54, 9 times 6. Okay, so they are called multiples of 6. And similarly for 8, we will have 16, twice of 8. What's next? 24, 3 times of 8. 32, 4 times of 8. 50, 5 times of 8. 5 times 8. 58, 6 times 8. 48, 6 times 8. 56, 7 times 8. 64, 8 times 8. And 72, 9 times 8. They are multiples of 8. And among those multiples of 6 and 8, you will see that 48, 48, this number is repeated in two different lists. So they are called common multiple. They're called common multiple. But this is not a unique number repeated. You will see that this 24 is also repeated. And there's no smaller number repeated. So this is called the least common multiple. The smallest common multiple. Least common multiple. 48 is a common multiple, but it's not the least because 24 is also a common multiple. It's smaller than 48. So the least common multiple means it is a common multiple, it's the smallest one. Right? Okay. So in order to get least common, the reason we need the least common multiple is that you see here, the final denominator actually is the least common multiple. So if we know the least common multiple, we don't need the cancellation in many cases. For example, let's check. If we try to add 8 over 15 plus 5 over 12, let's try to find the least common multiple. Multiple of 15 will be 15, 30, 45, 60, 75, 90. So 12, 24, 36, 48, 60. You see? Yeah. 60 repeated. The first common multiple when you do this, and 72. Okay, so this is the first one, first common multiple. So this is least common multiple. Okay, so what do we do? For 15, how do we get 60? It's a 15 times 4. You see here? 15 times 1, 15 times 2, 15 times 3, 15 times 4. So we multiply top and bottom by 4, both. And 5 over 12, this is 12 times 1, times 2, times 3, times 4, times 5. So we need 12 times 5. In order to get 60, we need the least common multiple. Okay, 4 times 8, 32 over 60. Here's a 25 over 60. See, they have the same denominator, the common denominator. Then it is equal to 60. The numerator is 32 plus 25, 57 over 60. 57 over 60. All right, so that's good. That's good. That's a smaller. If we don't do this process, you see what we're going to do. We're going to, for example, if we don't know the least common multiple, what we're going to do? We're going to multiply first quotient top and bottom by 12, second quotient top and bottom by 15. Those numbers are huge. So we try to avoid bigger computation. That's the only reason. Unfortunately, this one you still need the cancellation. So 57 is a multiple of a 3. You try to cancel that. You divide the top and bottom by 3, you will get 19 over 20. That's a coincidence. You do this computation, you will have the same answer. Well, you are going to try to see if it is equal to 19 over 20. Cancel 3. Cancel 3. Check it. So the least common multiple is useful when you try to add two quotients, especially when you try to find the common denominator. The advantage is that you are dealing with smaller number, not huge number. For example, what is 15 times 12? It's 180, so it's going to be this type of number. What is that? 171, yeah. And 171, you still need to cancel. Step by step, after cancellation, you will get the answer, right? So you cancel number 9, you will get 19 over 20. The same thing, but those numbers are large. If the number is large, it will give you big chance to make mistake. So that's the only thing. Okay, so this is complete section 1.1. In this section, we quickly review the basic properties and the computations of real numbers. You need to check it and make sure you can do the right computation. It's about the computation. Okay, so in the next 30 minutes, not 30, possibly 30 minutes or 20 minutes. In next 20 minutes, we're going to start next section. Okay, do the recommended exercise, send me email if you have a question. Okay, we'll stop this video and continue next one.